You should now have a dual color LED connected to the GPIO extension board through the breakout board. We have the black wire ground connected to physical pin number 20 ground, and we have the yellow wire, which is the R pin, connected to physical pin number 12, which is GPIO pin number 18.
Go ahead and open up a terminal if you haven't already. Right now I'm in Lab 1.0. If I want to move back one directory, I can do cd space ... If I want to move back to the root folder, I can issue the command cd. Now that I'm in the root folder, I need to move back to my ATTC project folder. So I'm going to issue the command cd and start typing in desktop. As soon as I add the letters D and E, I can press the tab key. And then I'm going to enter into my project, so I'm going to enter a few of those letters and press the tab key again until I get into ATTC 3260 directory. Now that I'm in the directory, I'm going to look at the folders that are available. I'm going to issue the ls command. After the ls command, I want to navigate. I can see there is a lab 2.0. I want to navigate into that folder or directory. So I'm going to issue the command cd space and then start typing out lab. If you press the tab key here, it's going to stop at the B. The reason for that is there are multiple directories that have lab as the first three characters. So if I put in A2, then press tab, it should finish out the directory. Now that I'm in the directory, I want to see what files are available. I'll issue the ls command. You can see that we have several Python files inside of this directory, and we want to be able to work with them. Just to ensure that I have the latest code, it's always good to execute a git pull. So I'm going to do a git pull, and in my case I have new information coming in. As a reminder, if it says already up to date, that indicates that you have the most current git repository files. We can now close the terminal and go into Thonny editor. And I want to open up that lab, so I'm just going to go File, Open, and if I hit this button there, that'll take me back and Lab 2, and we want to work on Lab 2.1.0. I'd like to talk about the code that we are about to execute in order to turn on this LED. If we see on the first line, there's a hashtag or £, and then an exclamation point and some text. The hashtag or £, is used in Python in order to indicate that this is a comment. A comment is a way for us to be able to provide information to anybody that's reading our code so that they can understand what the logic is that we're using. The computer does not execute or do anything with these. It ignores anything that's in a comment. So you put comments in your code in order to help other users understand the logic that you are utilizing. Right underneath our initial comment, we have a keyword that's highlighted here, and it says import. Import means that we are getting information that is available from another file that was created by a different user. In this case, we are getting the Raspberry Pi GPIO library. The library contains the information about a Raspberry Pi and enables us to use some of the commands that we'll see below, like set mode, setup, and output. When I add the keyword as and then type in GPIO, that allows me to use the shortcut variable GPIO anytime that I'm trying to reference this specific library. pin_r is a variable that we've created. The variable is in place so that we can use it in more than one area in the code. It also allows us to assign a specific value to pin R. In this case, we're assigning the value of 12 to pin_R. That means that any time that we use the variable pin_r in our code, it replaces pin_r with this value of 12. The benefit of doing this is that we can change pin_r to equal a different number. If we change pin_r equal to 14, all the instances of pin_r in our code would equal 14. We are now going to use the alias GPIO that we assigned to represent the library, the RPI.GPIO library. So here we say GPIO dot. The dot is a way for us to gain access to a function that is inside the library. The first function that we are accessing is the function called setMode. SetMode allows us to set the mode or method in which we want to use in order to number the pins of the GPIO. You should recall that we have two different methods in Python that we could use to label the position of a pin on the Raspberry Pi GPIO. The method that we will be using is the physical pin location. In this case, we'll be using physical pin location 12 in order to assign that the value of pin_r. We could also set this to the BCM value. The BCM value of our current pin is BCM number 18. In order to avoid confusion, we're going to always be using the physical pin location. So this line of code establishes to the library and makes it so the library is using the physical pin location instead of the BCM location. We next need to tell the Raspberry Pi how we want to utilize the pin that we have selected. We'll use the alias GPIO, and now we're calling a function. This function is known as setup. Setup allows us to select a pin and determine whether it is an input or an output. Here I'm using the variable pin_r, which is replaced by the value of 12, and then the comma indicates the second parameter that I'm sending to the function. The second parameter is using the alias GPIO and designating that this will be an output pin. You'll notice that I have a comment next to this line of code that says those same things. Remember, that comment is only so that it makes it easier for someone else who is reading your code. The Raspberry Pi does not process or utilize that information when executing the code. We have assigned the mode to use the physical pin location, and we've now set up pin R, which is the physical pin number 12, to be an output. Finally, we have to tell the Raspberry Pi what we want to do with the output. So I use the alias GPIO and type in dot, and now I'm calling a function. This function output takes two parameters. I first need to pass it information about which pin do I want to do something, and the second parameter is what to do with that pin. So here we're saying pin_r, which is the variable given the value of 12, and GPIO.high indicates that we want to set the pin R to high, or 3.3 volts. This should then turn on the LED with the current way that we have wired it. Great, now let's go back to the terminal, and we want to execute this Python code. I'm going to use the keyword Python and put a space, and now I want to access that lab. If I push 2.1 and then tab, there are several options for that, so I need to do 2.1.0, and then if I press tab, the terminal will add the remaining portion of the lab. Now I press enter, and I should see the LED illuminate. Nice work. You've executed your first Python script using some hardware. We've been able to illuminate an LED. If you have any questions or problems with your LED, please see your instructor.